Good morning, students. Today I have come with a new problem in kinematics rectilinear motion. The problem goes like this. The position of a particle moving along a straight line is defined by the relation x is equal to t cube minus 9t square plus 15t plus 18, where x is expressed in meters and t in seconds. Determine the time, position and acceleration of the particle when its velocity becomes zero. So in the question, he gave us only one simple equation, that is x is equal to t cube minus 9t square plus 15t plus 18. That means x is actually the displacement and t is the time. Now how do we know x is displacement and t is time? In the question itself, he gave us x is expressed in meters and t is expressed in seconds. So generally for displacement, the units are meters, and for time, t is seconds. So I'm just considering that x is displacement and t is the time. Okay, now what exactly is this x? It is simply defining the position of a particle. For example, I'm considering a straight path on which there is a particle. Now it is in the first position. Now after reaching to a particular position, let us call this one as the second position, right? It has displaced some distance x. There is some displacement, right? Now as it is moving in the forward direction, the movement of this one is governed with respect to time, and at a particular position, the position of this particle is given with this equation. Now in the question, they have asked us to determine the time, position and acceleration of the particle when its velocity becomes zero. So when does the velocity of any particle become zero? Either it has to start from the state of rest, then its velocity will be equal to zero, or when the particle is moving, when it comes back to rest, then its velocity will become zero. Okay, now as the first equation, which is the displacement, now we need to find out velocity. Now how do you know, or how do we find the velocity of any particle when displacement equation is given to us? So from the lower classes, we have learned simple things, right? Like when x is the displacement, dx by dt, rate of change of displacement with respect to time, can be taken as velocity. Whereas rate of change of distance with respect to time can be taken as speed, as you all know this thing. In the horizontal direction, right, dx by dt is taken as velocity, which is v. Now I'm differentiating the first equation, dx by dt, which is equal to d by dt of this entire equation, t cube minus 9t square plus 15t plus 18. Now whatever the dx by dt, we see here, it is the velocity. It becomes velocity, that is equal to 3t square minus 18t plus 15. Now let us call this one as the second equation. As first equation is representing the displacement, second equation is representing velocity. Second equation is representing the velocity. Now in the question itself, he asked us to determine the position and acceleration of the particle when its velocity becomes zero. So velocity becomes zero. That means I'm just equating this entire equation to zero. 3t square minus 18t plus 15. Now this is equal to 0. Now when I find the roots of this equation, I get the time t is equal to 1 second as well as 5 seconds. The roots of this equation, t is equal to 1 second and t is equal to 5 seconds. Okay, when I got the time t is equal to 1 second and 5 seconds, the roots of this equation. But they have also asked us to determine the acceleration and position. To get acceleration, I am just considering equation number 2. V is equal to 3t square minus 18t plus 15. This is equation number 2. We know that dv by dt, rate of change of velocity with respect to time, is called as acceleration. So I am differentiating the same equation. When you differentiate the above equation, you will get 6t minus 18. Let us call this one as the third equation, that is acceleration. Acceleration. Now, in the question, we need to determine the position as well as acceleration. For t is equal to 1 second, we got three equations here. X is equal to t cube minus 9t square plus 15t plus 18. Now, when you substitute t is equal to 1 second, that will be 1 cube minus 9 into 1 square plus 15 times 1 plus 18. Now, calculating this entire thing, we'll get the answer as x is equal to 25 meters. Similarly, when t is equal to 1 second, we got the velocity v is equal to 3t square minus 18t plus 15. This is just to cross check whether you are doing it correctly or not. So whatever the thing you will get, it is equal to 0. So in the question, whatever he gave, it is correct. That means velocity is 0 and we are going in a correct path. Next, we have acceleration. A is equal to 6t minus 18. So substituting t is equal to 1. 6 times 1 minus 18, that is equal to minus 12 meter per second square. So you are getting a negative value here. What does that mean? It is deceleration. It's not acceleration, it is deceleration. Now similarly, for t is equal to 2 seconds, sorry, it is 5 seconds. T is equal to 5 seconds. When you substitute t is equal to 5 seconds in the displacement equation, we get the displacement x as minus 7 meters. Displacement will not be negative. We got the answer as negative, as well as the acceleration a is equal to 12 meter per second square. Just substitute t is equal to 5 seconds in the acceleration equation. You will get the value of acceleration as 12 meter per second square. Now these are the very important questions. So they may be coming in the examination also. Thank you.